Hello, everyone. Welcome to this, our Rules as Code Masterclass with SmartLegal and Business Rule Solutions, our second masterclass in a series of 4 masterclasses brought to you by the Australian Society for Computers and Law. Now, let's begin by acknowledging the traditional custodians of the various lands on which we meet today and the Aboriginal and Torres Strait Islander people participating in this webinar. I pay my respects to elders, past, present and emerging, and recognise and celebrate the diversity of Aboriginal peoples and their ongoing cultures and connections to the lands and waters of New South Wales, Australia. I am Natalia Sinamarkovic. I lead the Australian Society for Computers and Law Future Law Working Group, and in my day job, I lead APAC and Oceania Law Technology and Innovation at EY Law. For those of you joining us for the first time, the Australian Society for Computers and Law was launched by His Honourable Justice Michael Kirby in July last year, but we have a 40-year history in New South Wales. So who are we? We are a cross-disciplinary network of professionals, academics and other leaders working at the interface of law, technology and society. So we provide a forum for learned discussion and debate through our policy lab. We have various working groups, as I mentioned earlier, and our amazing events program, of which this is one. So the Society continues to attract support and engagement across Australia and globally. Do join us by subscribing to Australian Society for Computers and Law. As I mentioned, this is a second webinar in our series. So we ran a Rules as Code Masterclass with CSIRO as Data 61 and QUT earlier this month. And on the 11th of May, we'll be running a further masterclass looking at the OSLI DataLex platform. This is going to be a really special session because not only will we be demonstrating SmartLegal's tech platform, but we'll be doing so by taking an end-to-end approach. So many of you won't need reminder, but tech is an enabler only. And it's actually the process and the people expertise, mainly in these types of projects, multidisciplinary of course, that ultimately drives success. So let's turn to some quick bios now. Today we have Adrian Kelly, Gladys Lamb and Mike Ferguson presenting. Adrian Kelly is a lawyer and one of the founders of SmartLegal. He has 20 years experience in commercial and administrative law in New Zealand and is currently the New Zealand parliamentary drafter. For the last 5 years, Adrian has been developing software to deliver rules as code for the emerging digital legal system, both in New Zealand and globally. Gladys Lamb joins us from Canada. It's very early in the morning for you, Gladys, so thank you for staying awake for us. She has a background in computer science and an extensive resume in consulting. Gladys is principal and co-founder of Business Rule Solutions. She chairs the steering committee for Rules as Code Excellence Awards and is co-founder of the brcommunity.com. Gladys co-authored Building Business Solutions, Business Analysis and Business Rules, published in second edition, being published in 2015. Mike Ferguson is co-founder and CTO of SmartLegal. He holds a patent in the use of recursive reduction patterns for code generation. He has extensive global experience in finance, dealing rooms, back office, government integration, reconciliation, business intelligence, transformation, and re-engineering. So before we kick off, I'd like to ask you the question, please, presenters. Adrian, Gladys, and then Mike, could you please share a bit about how you became involved in Rules as Code and what excites you about this field?
Sure. I got involved quite a few years ago now, talking to James Every Palmer QC. We were talking about blockchain, in actual fact, at that stage, but also about computable law. And he suggested that we write a language to capture the logic of the law and to make it computable. And I said, well, we don't need another computer language, but I ended up doing it anyway. Then I met Mike, and and we moved through the better rules process for the New Zealand government, and we've ended up here. What excites me about it, and the reason why I do this, is the outcomes for businesses. Rules as code for me is going to allow people to bank efficiency gains and certainty gains around their legal obligations, right? And that's gold for business. We're talking about compliance for business here, and the same with individuals. I mean, you can have a personal relationship with the law. Digital law is repeatable, it's cheap, it's efficient, and it provides certainty. And you can put your data into that system and have a personal relationship with the law, obligation-wise. So that's what really it's about for me, is access to the law. I'm a lawyer. I've been drafting New Zealand's parliamentary law for 16 years now, and it's all about access, and it's also about reach of regulators. Everyone wants certainty. Everyone wants efficiency. And it seems to me, and this is what James Avery Palmer was on about. I mean, we've got computers. Digital computers are very powerful, right? And we use it to compute. We use them to compute where the moon is and where the sun is, and ballistic missile tracks. We need to harness that power, for other kinds of rules, not the rules of nature, but the human rules. I mean, and they're two different things, but in the final analysis, they are algorithms, right? We're talking about algorithms that are going to be useful in people's lives, and rules as code is the way to realize that computer power in people's lives. And that's what it's about, is taking that power and applying it to this area of human endeavor and making it better. So that excites me.
Excellent, Gladys.
Yes, I started getting involved. Well, as the name suggests in our company, Business Rule Solutions, it's all about rules. And our company's been around for 25 years now. So I think quite a few years back, we brought our training and approach to New Zealand, and the New Zealand government adopted the approach, and on rules, decision, concept model, and all of that. And that is used as the basis, as the approach for the Better Rules initiative, which we will be talking about later. And that is the beginning of rules as code. So for us to watch this happen as it unfolds, it's just amazing. And we're very honored and excited to be part of this movement. And just working with rules all these years, we see how beneficial it is to look at things from a rule perspective, from law, from legislation, and how it can efficiently get into code. And seeing that is just, groundbreaking, and very excited to be involved. And my other business partner, Ron Ross, in Business Rule Solutions, is known as the father of business rules. And he was involved with the primer that came out in Rule as Code, and he's given feedback on that. So we're quite involved, and we're excited to do that.
Awesome. Mike.
Cool. So I'm at the technical end of it. I talk to computers like I talk to people. So for me, I got into it because I realized that computers break things down into little pieces and then follow out each instruction at a time. It's fascinated me since I was 12, since I first got my hands on a computer. But the thing that really excites me about it is that you can do the same thing to law. You can break it down and you can turn it into little things, and you can associate a computer with the law. And it's amazing to me how far down the line you can go. And working with Adrian, law itself is very simple. There's so much complexity in it, but it's very, very simple at heart. And separating that complexity away and saying this is all of the unsolvable stuff, and just concentrating on the stuff we can solve, that's absolutely fascinating. And that means that each person can then have all the network and the connections of all the things that give them this personal view on law. And then they should be able to then just navigate using a phone or whatever their device is. And then all of these people working together with their phone and devices can get rid of all the drudgery of law, all the working through the documents, trying to understand what that means and what it relates to another thing, and creating these great long lines of things, and come out with cleaner outcomes and more traceable outcomes. And ultimately, on a larger level, that means that the people can put out a big what if this happens in law, and what if I do this? It's all about the individual. or the group does this. And then that transforms into a, well, what do I do now? That becomes the target. So using lots of what-if scenarios, you can actually start planning for the future. And so ultimately, it's the removal of drudge, and that means you can concentrate your effort on the important things, the things that the computers can't solve, the questions of what it is. And the system that we've written, it can write in any language. It's not limited to English, and neither is law. And then further, it also goes as far as any computer language. And whilst doing that, it maintains a transparency at every level, a proof of value for every change. And that's like a navigation and an assurance of personal law. So for me, it's a very personal thing, and the computers can do it now. We just have to accept that they can help us.
Wow, what an exceptional panel. Thank you so much for sharing your stories. So what will we be doing today? Adrian will set the context for Rules as Code for those of you who join us today without a background in RAC. Then Adrian will hand over to Gladys and Mike. They'll take us through a live case study end to end. Gladys will be sharing her extensive experience and engaging slides, like focusing on the end-to-end process. And then Mike will take over and demo the tech. Now, over to you, Adrian. Thank you.
Thank you, Natalia. Natalia's basically outlined what I'm going to say in broad. We're talking about an end-to-end process here. Rules as Code is not just a technology platform per se. I mean, it is a technology platform. It is data into the SmartLegal platform, and out the other end pops beautiful code that's flexible and integratable. And so we could just demonstrate that. We could say, well, you type this in, and then magically, and it is kind of like magic a little bit, because computers are a little bit like magic, out pops this beautiful SQL code, and we have rules as code, and we can give that to people, we can give that to businesses, and we can give that to individuals in various formats, and they can interact with it. But before we get to that magical place, you've got to have the data, right? And so that's an end-to-end process. People create the data to put into the platform. And what we're going to do today is we're going to see one of the major use cases. I mean, obviously the data source can be already published law, or it could be like actually policy that gets put into law itself. So we're talking about an end-to-end legal system process here, where you might start with an idea. You don't even have a written rule set right, but you can actually use the digital modeling tool that we're talking about to model rules that eventually become rules as code. Gladys is going to explain this. This is the better rules process itself. So I'm not going to go through that. Gladys is going to do a little bit of historical background about the problem definition, and how we saw in the better rules process the need for a comprehensive reimagination of the legal system from a rules as code perspective. So we'll go through that, and then we talk about, and this Gladys touched on this already, we get through to the artifacts that we need. It's all about creating an algorithm, right? So we need that data in an algorithmic form for a computer to execute. So we have to get our heads around how rules really work in the law. We have to get our heads around how we analyze rules, how we create algorithms from the base material, and we'll go through that. And then we get to the technology, and the technology is fabulous in itself. So we go through this process of creating the data and understanding it in a transparent way. Then we'll see the platform in action, and Mike will give us a peek under the hood at the magic behind that. And of course, then at the far end, you get actual rules as code. And Mike again will talk about how that fits into people's digital ecosystems. And it's something that we're big on is you've got your rules as code, you've got an end-to-end process. The if you like, non-digital, the thinking part of it is as much as part of it as the technology, in that you get assurance as a human being that what's going into the computer is right and correct. I mean, it's garbage in and garbage out. Nothing is truer has ever been written about computers than garbage in and garbage out. So we've got to go through that process. We're going to use a real life use case, so Gladys is like the policy person, if you like, coming up with the rules. Mike's in the room with her. They're generating ideas and rules and concepts, and then they're also modeling them digitally on the fly. Now, we've done this a number of times. This is not the case where you get a set of rules given to you on a piece of paper and then you model them digitally. We're talking about a different use case. It's the one that I'm used to as a legislative drafter, where you're actually writing the rules as you go. So that's the context. We've talked about the artifacts that we're going to go through. We hit the data stream, we go into the technology, and yes, that's what we're going to learn today, how this all fits together. So I'll stop talking and hand over.
Thank you, Adrian, for the background. And let me just get started and talk a little bit about where we are and what is better rules. So we're gonna, as Adrian says, we're gonna use a case study and we're gonna use better rules. And the reference for better rules is here for anyone who wants to look at the full document. There are two references. One report came out in January 2018, and then a follow-on 2019. Now, before we go on, there's a little bit of a clip that I'm going to show that explains better rules really well. So stay tuned for that.
Better Rules, Better Outcomes is a New Zealand initiative that will enhance the way our government develops and implements regulatory systems and has attracted a lot of international attention. Rules govern the way we behave and operate. The rules are set out in legislation, which consists of Acts of Parliament and regulations. Simply put, Better Rules produces legislation in a digital format. That is, having particular types of legislation available in a code or code-like form that software can understand and interact with. Better Rules, Better Outcomes complements and enhances the current policy development process. The difficulty with legislation is that it is not written in a language that our digital devices and systems can understand. Currently, for legislation to be used by a device or digital system, humans need to translate and rewrite the legislation into software languages. Incorrect translation is a high risk for everyone. So what if legislation could be developed in English words and software code right from the start during the policy development process? Better Rules is a methodology that enables us to produce better logic expressed as concept model, decision trees, and rule statements. Together, these create a blueprint of the legislation, which then set out the rules of a regulatory system. Using the blueprint, we can write legislation in any language, for example, English words and software code. That software code can then easily be used in our devices and systems to assist people and businesses to understand, benefit from, and to comply with legislation. The Better Rules approach involves working in a multidisciplinary team using human-centered design techniques. Together, they design the overall regulatory system to ensure it focuses on the needs of the end users of that system before any legislation is written. With the software code, we can test the overall legislative framework to identify gaps in the logic and the rules. The policy-making process becomes more agile and responsive to the needs of citizens. The software code is made publicly available, reducing duplication of effort and reducing the translation risk. So, who benefits? Those who create regulatory systems, those who interpret them, and those who experience them. Better Rules is a collaboration between multiple New Zealand government agencies. And remember, the rules of our regulatory systems are still developed by humans for humans. So don't get left behind. Get on board for better outcomes. Visit betterrules.govt.nz to find out more.
Okay, and my goal today is to show you how this Better Rules approach work. So I'm going to walk through actually a lot of the reports how they go about doing that, and how some of the techniques are applied. And then Mike is going to show, as I go through each of the concepts, Mike will come in and show how the tool works. And so pretty exciting. So the goal, this goal is the Better Rules goal. And the goal is to narrow that gap between policy and the actual delivery of those policy into systems. Just a little bit of background. Current state before Better Rules is legislation, policies being think through, walk through, written by a group. And then when that's done, it kind of get lobbed over, thrown over to service design delivery, and they code that legislation or policy in some system. Now, a lot of times what happens is things get lost in translation. The policy's intent is not always clearly defined, and there's not a whole lot of feedback. And so the current state, this kind of policy analyst doing something and then getting translated by rule analysts and then getting to software developer in this kind of approach is slow and doesn't have the feedback that we like. What we want in the future state or the Better Rules, what we wanted to practice is an iterative approach where policy makers and coders and rule analysts work together and then come up with policy, cycle through the policies faster and getting it from policies to code faster. And how for this to work is absolutely, you hear about it in the little clip that we saw, that multidisciplinary team that involved all of these people, rule analysts, designers, legislation drafter, policy analysts, strategic advisors, and software developers, all working together as one. And the approach they use, and this is the BRS approach that we've been teaching for many years, and this is one that they have adopted. And what you see is there are two bubbles on the side where we say create concept model and create decision structure. The way we look at it is, like Adrian said, there needs some thinking before you can go into really code iterative process. And the thinking, the structure, we call it the structure, the backbone of all of this iteration, fast moving, is in the concept model and the decision structure. And I'll go through what that means. And when we have that foundation, this foundation layer, we can then sprint real fast. And what do we mean by concept model? And let me just go through that very quickly. And here is the approach from Better Rules. And this is right out of the document. And when you go reference the document, you'll see exactly that approach. And I'm going to step that through with you. And in the document, in the Better Rules document, they actually work with two acts, rate, rebate, and holiday acts. Now, in today's example, we are not going to be using these two acts. We're using wage subsidy and rate subsidy. And so that one, we're able to show you all the way end to end. Now, step one, creating that concept model, and in Better Rules, that's one of their first step as well, their layer, concept model. What is it? What is a concept model? It's really just a set of business concepts, and we'll represent them as terms and definitions, and there's a diagram part and there's a definition part. And what is it used for? Concept model really is used to help you promote clarity of thinking and share understanding so everyone involved in the team know what we're talking about. And this is to avoid things like very technical speak or very legal speak, so that we can get into a shared understanding for common team members to understand. And illustration of that, we do a lot of this work all over the world, and this is an example of an electronic provider. They do electronic grids all over the country, and when we work with them, we realize load is a word that you use, a load on your electricity. And we find out there are 7 definitions of the word load alone. Okay, so that's one type of industry, but that applied anywhere. For social services, we work with some of the social services, and the definition of a child, for example, has 4 different definitions. So if you're offering some subsidy for child or for services for child, which one are you applying to? So clarity of thinking, common understanding is what concept model is about. So what does it have? What does a concept model look like? I don't want it to sound mysterious. This is what it looks like, the graphical part. So this is a concept model of a library. So you see on the bottom here, a little bit of a legend. A box is just a term, the name of the noun concept, and the lines are verb concepts. So we can communicate with nouns and verbs, and heavy dark lines and categorization. So you see a borrower, there are two kinds of borrower, person or organization. A borrower holds library card. Library card is used to check out the book. A book that's owned by library. You can see, and it's very simple when it's done this way. But what's more important than the diagram is the definition of each of these terms. So when we know what a book is, we know what fee amounts are, and then over and over again, just like I explained, that when we go into organization, there's so many different meanings on one concept. And so that's what this concept model is for. And in the Better Rules document, it talked about the benefits of the concept model, and you can see concept models enables the team to quickly and efficiently understand the area, and it also gives important to highlight the overall concept. And they actually even try a portion without a concept model, and they find that that's not efficient at all. So now let's get into how this applied and how it will work in the tool. So we, as I mentioned before, we're going to use wage subsidy as one of our examples. So this is a concept model on wage subsidy, and you see the individual, the different employment type. You can be full-time, part-time employee. So you have all of these terms represented in a diagram. And then also, this is just a clearer picture of one side. A business generates revenue. Revenue creates a wage and salary. And a business applies wage subsidy, and that wage subsidy is applied by a business. Now, underneath each one of these terms, there is definition. And you'll see that one of the definition is about full-time, working 20 hours or more. And I highlighted this because now Mike is going to show us how in the tool it deal with when we think through what full-time is, with defining all that. Now Mike is going to take over how it's going to be represented in the tool.
Cool. Thanks very much, then, Gladys. Okay. Right. So what we're looking at here is just a workbook, and we're looking at a part of the system called log law. Now, log law is a bridging language. It provides the necessary connection between the human experience and the computer experience. So if we look at what we were just looking at there in one of the rules, is full-time employment. And we've basically taken the terms from the concept model, and we've called that a log. That's actually the Greek word, logos, which has the meaning of meaning, straight out of the concept model. And then we've associated that word, which is full-time. What does that mean? It's a short term. And then the actual written meaning in law. So, and law literally means what is right. And we're taking the data dictionary definition, the definition from the concept model again, of what do these things mean. At this point, we are going to start presenting it to a computer. So we've pulled out for the COVID-19 wage subsidy, all the definitions and all the terms. And you can see the linked terms here, part-time with employment period. That's where the bold lines were shown. And then what we're really trying to do is a computer. Now, the computer, it doesn't have this concept of things that sit still. The computer's always moving. It's always trying to give an outcome. And so what we're trying to do here is we're going to take that definition, that static definition, and give it a direction. And the best way to give it a direction is as a Q&A, a question and answer. And so in the case of full-time, the full-time definition is somebody who is in full-time employment. So really want to take that question and turn it into, are any of your employees in full-time employment? And that question then has an input and an output, and we can take that input and output, and that gives us a flow and a direction. All of these things are individually a question of law. Are you working in New Zealand? And this works in the same way as a computer. A computer breaks everything down into single things, into a single decision gate, and some electrons go into the decision gate and other electrons come out, and it takes that decision and it feeds it back around, and there's another compounded decision from that. It's the same thing as a computer. All we're doing is we're breaking every statement down into a little decision gate. Ask a question, get an answer. We do this using a new career for anybody out there who's keen, which is that of the legal engineer. So a legal engineer's job really is to understand and manage the bridging between the human sentences here and what we'll show you later, which will be the computery style sentences and associating the two together. And they look after the transformation of a definition, a legal definition, into a legal question, which requires a level of skill, because if you get that question wrong, then you're presenting something that isn't true from a legal point of view. Now, the legal engineer is providing assurance at this stage, and most people can have a go at taking a legal statement and turning it into a question and saying that that is assured. And so we've ticked off that first box of we're okay and everything's comfortable here. We're working inside this log law, and this is working. It's effectively a foundation for how we actually build the engine based upon the engine that Gladys has been shown before. Not the engine, but the process that Gladys has been shown before. And this is the start of really what is a full stack of transparency going all the way back to concept modeling. Remember that multidisciplinary team has all agreed on the meaning of the terms which are appearing here. So they've all agreed on the meaning, and the data definition has been agreed, and the legal engineer has transferred the law into a question. And everything has been agreed, and we have full assurance so far. Now, going on from this is the concept of decisions and how you make a decision using these, and that would feed into decision support. And so Gladys is going to take you now into the area of decision modeling and what that means and how to pull that out of the law. Please take away, Gladys.
All right, so remember the first step, I talked about there are two fundamental layers we have to work through. One is the concept model, getting those clarity of thinking, discussing, okay, it's full-time, 20 hours, 30 hours, 45 hours, whatever it is, get that right. And then we hand it over, the developer gets involved, because the developer really don't care whether it's 20 hours, 25 hours, or 40 hours. That needs the thinking work ahead of time. And then now, like Adrian said, garbage in, garbage out. If you get that thinking, you get it right, then Mike comes in and he does a beautiful job getting it into the tool. So the next part now, the next step is what about those rules? Sometimes you have such complex rules, a huge group of decisions to come about. So when you have that type of rules, that a whole large group of rules before you can make a decision, this is where the other fundamental piece, the decision structure. And in better rules, that's also their second layer, their approach. They call it decision model. Our methodology calls it decision structure. So what is it? Again, I don't want to make it mysterious. And the decision structure is used to break down complex rules, to help you think through complex rules. And our technique for that is called questions chart, Q chart. And because you can phrase these complex decisions in a question form. So here's an example for mortgage. Should a mortgage application be approved? So all of us have applied for mortgage or loans or eligibility, like club membership. How do you approve something? And you can imagine the amount of rules that go in to see whether you're eligible for mortgage, whether you're eligible for claim, or so forth. So, at first when you look at that, oh, that's so daunting. What does it involve? The way to do that is to break down that decision into sub-decisions. In the case of mortgage, you evaluate it based on 5 C's. That's really common in the financial industry. Whether you have the capacity to pay, whether you have capital or have good collateral, and you have in good conditions, and also how's your character. So now, when you get down to the layer as next layer, is slightly more manageable, but it could still be huge. So you take any one of these, how do you know whether you have enough capital or collateral? So then you take any one of these, collateral, for example, and then you say, well, what does that involve? There are sub-decisions in that. Is your loan to value, is your property type acceptable, is the location acceptable, do you need guarantee? So every one you break down more until you get down to the rule level, because this is just a structure to help you think. And then you get down to, for example, in this one, collateral, is the location available? Well, you know what? There's a rule about whether a location is acceptable. A location must be considered unacceptable if any of the following is true. If it's a fly-by community, if it's a single industry town, that's not acceptable. They won't give you a mortgage for that, for this financial institution. And then it even drives down more. Well, what do you mean by a fly-by community? And it actually breaks down what the rule for fly-in community means. So that's how we take really complex, a lot of rules. And you can imagine there are a lot of other rules to get at the other C's, the other decisions, to come up to finally, should a mortgage application be approved? So any one of these rules can go into the tool for implementation, but this is, again, the way to break down, to think before you code. And just one more illustration on the question chart. This is about applying for auto insurance. It's broken down into 3 sub-decisions. And then now, even in one of these sub-decisions, there's a lot of thinking. Is an applicant's driving status acceptable? Well, how do you think about that? How do you know if it is or not? Again, we have an approach. Break that down even more. So you start with the question, we call it QCO. It has question, consideration, outcomes, and exception. You start with the question, is the applicant's driving status acceptable? And then that's the question you want to answer. The outcome is, yes, it's acceptable. You're eligible, non-binding, or ineligible for insurance. What are the things you have to consider? And for this decision, you consider whether it's a provider and what kind of applicant category, and whether there's exception. So in this particular decision, we can bring it out in a decision table. A decision table is just a set of rules. You can see the list of applicant driving status on the left, whether you're uninsured driver, readmission, uninsured non-driver. And then on the right, there are different providers and different insurance providers. And under a certain insurance provider, you're ineligible or you're eligible. And it just shows you that. And the exceptions, if you're a felony, if you're a felon, you're not accepted. You're underage, you're not accepted. So you write the rules on that. So that gives you, it's just one technique of breaking down really complex rules. Now, going back to our example, wage subsidy, and you can see to get wage subsidy, there's a lot of decisions on that too. The higher up one is the business eligible for wage subsidy. Well, is it? How can you tell? Well, there are three subdivisions. Is the employee, I think employees are legally employed and working in New Zealand, and also whether the business has lost revenue and also what type of business that is. So there, again, you can see the decisions breaking down and all of the considerations in each of the decisions. And from there, and Mike's going to show us how that works in SmartLegal.
Thanks, Gladys. So back to this example again. What I'm going to do, this was all very flat. So there was only one thing and there's one question, one answer that didn't go anywhere. So I'm going to add in all of the glue. This is the technical bit. So hold on to your hands. We're getting technical now. So if you look at this full-time example here, there was the question at the top here and the questions that sit underneath it. And you'll see that a new line has appeared, and that is the glue, the part of the process that the computer gets involved in. Now, I'm going to talk about an area here. So I'll just read out what is actually happening here. These terms you can see listed have a name, and that name is appearing here. So if week, and it's referring to within the full time, the week, and the year, and it's referring to this year here, and the employment period, here's the employment period. If all of these things are true, then your employees are in full-time employment. So that's exactly as Gladys was showing it in her diagram, except that we don't get asked this question. The computer can answer that question based upon that associated line. And they're both associated with each other through the use of the same log. Now, each of these terms themselves could be broken down, but I don't see anything sitting underneath this, nothing sitting there to say there's a computer is speaking here. So what we've got is three questions that are basically relating to this question here, and as a group make up a single block of logic or a module that is fed up the chain. So we can actually see full-time turning up here on the type of employee, and that type of employee itself is also turning up in here as a return condition. So if you're legally working, which is if you have a New Zealand work visa and your type of employee, and that passes up to the legally working passes up to here as an outcome, which gives us a type of business, which once again is passed to another one, a little pair here, which is your business eligible if the type of business is true, or you're legally working. And so what we've done here, using the logs and putting the logs into these actual computery statements, I'm going to describe what they are in a moment. What we have is a chain effect that happens, which is question, answer, raises a question, which leads to another answer, and that causes a little daisy chain of questions. Well, it's a collection of daisy chains, actually. So, and if I look at the model of that, they look like this. So they all chain up and work their way through. Now, I'm going to talk a little bit about what the form of logic this is. Now, this is, there's two forms of logic, really. There's things that you can work out and things that you can't. They're deterministic and non-deterministic. Things that you can work out, things that you can't. Now, the deterministic computers are really good at doing millions of records a second, trillions. The non-deterministic humans are really good at. We can just have an opinion on anything. And so the deterministic things, they're predictable. They'll always have the same outcome. If I run this model through, and you can see a bunch of yes no's and the don't no's going in over here, and they're working through the model, if I run this model again, the same outputs would come through. So they're predictable, they're repeatable, and they're provable. We can actually go back and say, a legal engineer can go back and say that this statement here, this little collection here is true, as long as type of business is tied to something which has a meaning, etc., etc. And so the legal engineer can accept that that's okay, give us assurance that that is the meaning, and pass that responsibility onto the computer, which can hold on to it and execute inside a computing system. And it basically consists of, if this equals that, then this happens, else that happens. Propositional logic, it's known as. The other form of logic is, we call it Diontic Logic, which is the law of obligation, the should you, shouldn't you. It's a bit wishy-washy. If I were to, I'll just read out an example of the Diontic Logic now. I use this one, anybody who has a child will understand this. So here's a bit of propositional logic for you. If you do not tidy your room, then there will be consequences. Now, computers can implement that, and they're very strict. Now, every adult tries a little thing out where you say, well, I'm going to try reasoning with the child, okay? So we'll see how that goes. And so I'm going to ask you another question here. Should you decide not to tidy your room, there could be consequences. Now, if I asked a computer to implement that, it's going to go away and not know what does that mean. Could be. What does that mean? Is it happening or isn't it happening? And children are very much like that. However, there is a difference there. The propositional stuff is a computer can make it happen, and the Diontic stuff is it may happen, but a computer can't work it out. And it's because of this difference that computers have very, very tidy bedrooms. Now, if I look at that link between a human and computer, we've got computers running away, implementing the deterministic, the actual propositions, and running them through in what looks like a hard deterministic skeleton. And we rely upon the humans to calculate the non-deterministic stuff, the questions that are floating at the back here. Everything else, this outcome, is fully determined. Whatever answer I give to this, the rest of the engine will pass it through and give me a deterministic answer. And the legal engineer, their job is to just manage these logical connections between each entry. So that then fulfills propositional logic. It fulfills the need to understand and computerize the ands and the ors and the structure of law, whereas it gives us a framework to which we can take the deontic, the unsure stuff, and pass them up the chain so they can be framed as a question to the user or the consumer of the law. And so, but the laws get more complex than that. I mean, obviously that's very simple. If we go down here, look, there's a really scary calculation here, a bit of computer stuff, and maybe some kind of more complicated questions regarding 40% decline and some calculations. So how do we pull those out? And what is a rule like when you pull it out of a legal framework? And so Gladys is now going to take us through disassembling rules and structuring them so that we can offer them to the computer. And then I'll do a live presentation and actually implement one of the rules and make it run. And you know what, I'll even show it on the phone. So over to you, Gladys, and we'll talk about decisions.
Okay, thank you, Mike. All right, so now, again, a reminder that I just talk about the fundamental things, concept model, for just getting shared understanding within the team of what things mean, and then decision structure for really complex rules to break them down so you can think them in a manageable, break them down to manageable chunks so you can think about them. Now, once when we have those fundamental things out of the way, Now we're ready for what we call rule sprint. You can now do this iterative process and get at drafting policy, rules, and code all together. And this is the third layer in the better rule approach. In their approach, this is their third layer. And what does it look like? This is one of the examples they used. The left-hand column is really the legislation. And the middle layer is, they call it pseudocode. It's really what we would call, our technique is rule speak. It's applying the rule, a structured way of thinking about the rules, using the concept model, giving you that structure, and then that gives you the source to go into the software, because you now have more structure, more deeper thinking than maybe at the layer of the legislation. And we can talk a little bit more about that. So let me bring up our library example since I walked through it. Remember, I brought up just the concept model part, walk through what the concept model is. Now I put in a rule, and you see the rules on the bottom. And if I just read through the rules, you'll notice that the blue should match with the terms on the concept model, and the rules very simple. A library card may be used to check out a book only if the book is owned by a library for which the card is authorized. Now, if you read this carefully, you'll notice that, and I did this purposely, that there's one term that's not on the concept model. And I do this purposely to make the illustration. You'll notice that it says for which the card is authorized. It didn't say library card, it says card. Now, for us who wants to make it clear, card could mean a Visa card, a credit card, not necessary library card. Now, then that will bring up the conversation, do we have another concept of card that's beyond library card? And so if it is library card, we'd like to see library card. If it's another type of card, we would adjust the concept model to show the other type of card. That's kind of the precision we like to see to get the rule to, so it matches up to the concept model. And again, definition behind the concept model is important. And we go beyond just the terms. We like to match up even the verb phrases, so we have consistency on the rule statement. Now, another example, and a lot of times rules, when we first see it, it seems like simple and we understand it. But once when we have the concept model, we can actually check the rule. So let me walk through the concept model. On the left-hand side, this is about a mortgage, getting a loan for a mortgage. So you have a party. A party completes a loan application, and when a party completes a loan application, we call that party an applicant. And the loan application requests finances for a property, and that property would be called the subject property. And the loan application is listed on a property, and that property is called collateral. And a party can have income, and party can own a property or can lease a property, and a party can have income, and a party can be subject to litigation. A property can have income, and it can be subject to litigation. Now we have a rule. Income must be greater than 20% of estimated value if subject to litigation. Now at first read, okay, well, you kind of understand that. Do you understand that? Right, but as we look at the concept model, there are a lot of questions. Which income? Is it the income of the party, or is it the income of the property? And then which is subject to litigation, because the party can be subject to litigation and the property can be subject to litigation. And also, which were concept used to interpret the rule correctly on income and estimated value. Is it income and estimate the value of the property, of the party who owns the property? Or is it the income of the party who leases the property? Is it the party who completes the loan application? You know what I mean? There could be so many different interpretations of this. Until then, we might have to rewrite the rules. And now we'll rewrite the rule: the income of the party who completes the loan application requesting financing for a property must be greater than 20% of the estimated value of the property if the property is subject to litigation. So now we are more precise, and we have a trick to make that rule. It's quite wordy. So instead of this whole long phrase of the requests for financing, actually an applicant is someone who requests for financing. So we can write this rule: the income of an applicant must be greater than 20%, la-di-da. So now there is clarification on the rule. That's the precision we're after on these rule statements. And so going back to our example now, and this is exactly what the Better Rules team did. So there's legislation, and I want to say that this is for wage subsidy and for rate subsidy. Actually, the legislation is already written, and it's after the fact that I think the team employed the methodology to document things. But for I think the Holiday Act and the other act in Better Rules, they actually use this discipline to work, develop the policy together. So here, the example is there's legislation, there is pseudocode, or we call it rule speak, applying the techniques I talked about, using the concept model, making things precise. You see the highlighted words, person, retirement village, subsidy, all that is in the concept model. And then we can, from there, we can do code, and then we can, and also make the policy more precise. And so let's look at what Mike is able to do with these rules now.
So we'll switch over to the rate subsidy example. So to reiterate where we were at, we have this concept at the top level there, which has the log and the law meaning for that, for both a human and for the human and the computer here. So this is like the computer definition and the human definition. You can see the log word here is being referred to over on eligible, and then there's a human meaning and the computer meaning of that. So if you're a ratepayer, you get a rate subsidy amount, and here's ratepayer over here. Are you eligible for a ratepayer subsidy, which is made up of if you're a ratepayer and you're residential and you're resident, and you can see those in the color over there. So a computer can ask these three questions and get an outcome all the way up the chain. So we can actually look at that in the model, very simple model. So, and this model is currently at rest, meaning that nobody's asked any questions, it's just running everything through. So I can see there's a question in the QA there, which is, what do these colors mean and why do they change? So I'll explain it using this simple model. So we have a no, I don't know, and yes. And there's three options, and there's three options and another three options and another three options, which is 3 times 3 times 3, which is 21, which means there's 21 possible outcomes. And the chance of that and that and that being green is 1 in 21, because it's that and that and that, whereas the other ones are different distributions. So the actual number over here, so the one chance of getting through here, if you said all the answers, and the other proportions. So it actually shows the weight of the law, the proportionality of it. So to reiterate over here, we've got the breakdown, and now what we're going to do is we're going to take an example. We're going to add in a new case, and we're going to press the button. I'll show you the button first. This is the home screen, big green friendly button. So that's the technical part of the exercise. So once you've defined your log law, you can then just go and press a button. And so the button will then go away and send all of your log law up into the cloud. It'll write the code and deal with it. We'll see that in a moment. So what we'll do first is we'll just open out the notes on here, and we'll just bring in that 2018 amendment. So I'll just show you where that came from. So here's the actual business description of the problem. We want to bring in the 2018 amendment and add it in. So and I'm going to accelerate the development and fast typing. So in reality, it takes quite a while to get these legal statements correct. And it takes a little bit of debate to understand and create that propositional statement. But once we've done that, if I were to just type it in, there's 2 minutes of effort on the typing side. And so we've got the eligible question here, and you can see that the retirement village is very similar to the ratepayer. Here's the retirement village question happening here. And the question is very similar. Are you eligible for her? And if we work down, the actual contribution is different to being ratepayer. They both bear the same residential term, although the definition of residential within retirement village is different to the definition of residential within ratepayer. Once again, if you think in that previous slide how we had to narrow in on the definition and make sure that's written in, and these can be sent up. Now, I'm now going to recklessly start pressing buttons. Then what happens is the log law from the spreadsheet just gets sent up into the cloud. The code is written. There's 1,000 lines of code for that 2018 amendment. That 1,000 lines of code is then deployed into the cloud, and then a model is run, which runs every possible outcome through. In that one, it's like 700 possible outcomes, and you can see it running through each of the outcomes here. And then when it finishes running through all the outcomes, it then plots it out as a diagram for us to accept. So we'll just have a look at what comes out of the model at the other end. Oops, gone down a bit. There it is. So I can see that there's the various questions, and there's retirement village come over here. Are you eligible for retirement village subsidy? Over here, do you contribute to the outgoings? And the question is, if you contribute in residential, then your retirement village will be true. And eligible is over here, all eligible, and that is if you're a ratepayer or a retirement village person, then you can come through on here. And so when we're running through these, we've effectively done all of the glue and all of the attaching together that we need to do to have this skeleton of law to which we can apply outcomes. So the outcomes pop out this way, and the questions go out the back and are answered by the humans, which are us. Now, I can take this a bit further, and we'll take this example, and we'll have a look at the actual calculation for that. So if I try and bring that up, and we'll move down a bit here. You can see there's the rate subsidy amount. Now, in the rate subsidy amount, there's a calculation. So we're actually into what is the rate subsidy amount. It's specified in the legislation. In this case, it's your household income minus a base rate divided by 10% of the rate and your dependents. And what I've done here, I've put in a set of default values to push through. And then the base rate is a fixed value that's actually named in the legislation. So I said, well, if we just go through with zeros and we say we have no dependencies, and then these things will attach to this calculation here. And you can see there's some computery things happening in here. A little star, that means that's computer speak or SQL speak, because it's actually talking in native SQL, which is the language of databases. The star means multiply, and there's a divide symbol. I think, you know, there's brackets, there's strange square brackets, whatever they mean, but they're actually pointing to that household income there. Is that household income there? There's the base rate over here. And so the answer to the question, what is your household income, which is 0, minus the base rate, which is 1,500, divided by, and you can see everything else. And then there's this strange case statement, whatever that means. It means when the rate is less than 1, then set it to 1. This is obviously to get rid of zeros turning up. So if you don't have a rate, or if you don't have any dependents, you don't want to see nothing coming out. And so there's a calculation here, which we can run through the engine. So we'll go and get it to do the deployment again. And so it takes all of that log law that we've just operated through, and it's going to write the code for it, and then publish that up into the cloud, and then make it available for us down here on Earth for outcomes, so we can actually look at those outcomes. So here it goes, it's publishing, and And when it actually does this, it can actually run locally on a machine, or we can push it out to a shared cloud, or it can be an on-premise style piece of code. The actual engine itself is pretty floaty. It doesn't mind where it lives. And that leaves us with the model, which is now just run, and you can see numbers coming through. Here's the base rate of 1,500, the household income question, the rate subsidy amount here, which is the calculation. And we can see the calculation through here, all feeding through to the rate subsidy. What is the rate subsidy you're eligible for? And if you are eligible, and you can see that there's one in, well, with the two ors, I think the possibility is one in, so we've got 1, 2 in whatever over here could possibly have that rate subsidy now, and there's a lot of doubt in here, and that's because we haven't actually changed any values, we haven't proposed any scenarios. It's basically just running through all the possible scenarios and working out the balance and putting them out through. At the same time, from the log law that we've done that have been published through the Go button, it's built this model, and it's provided also the data that underlies the model, underpins it. And so in here, we can actually see the different proportions of whether you get a subsidy. So if I look for the ratepayer rate subsidy amount over here, so there's a rate subsidy. I can see there's a rate subsidy. There's 3 instances of that. One of which gives us a no at 50%. The other one gives us an unknown at 43%, and 7% actually asks us to pay them for the subsidy. So there's something wrong in the logic. Now, because we put zeros through as a default state, normally you'd expect to receive money. You wouldn't expect one of those embarrassing newsworthy items where you get sent a letter with, you owe us for something we owe you. And so that leads us on to the final stage, which is once you've built these laws and they're in a computer, as you can see here, it's running all the possible combinations. It's running them really fast. And we can see all the possible outcomes. And while I'm at it, I can bring up my phone. Here's my phone. Here's the wage subsidy. Do you work in New Zealand? Have you got a work visa? Yes, and then it can ask the next question. In this case, I have a work visa, so I get the rate. And you can see it's gone green at the bottom here. And all the questions are lined up here. If I rerun this question and I don't have a work visa, then there's another question I could ask. And you can see the phone app itself, it's supporting that. So we'll go back to Gladys now to talk through how this testing fits into that. And then we'll start hitting the beast.
The last step here are better rules, and also into the code side now is testing. So in a lot of ways, the upfront thinking work is done. We've defined everything. We broke down the really complex structure of rules, and we've written the rules. So now we cycle through rule sprint, and we come up with the code. Then obviously the code needs to be tested. So here, Mike, do you want to talk to this a little bit?
For sure. So what we have here is any developer will go through the software development lifecycle, and they'll have to release some code, and they'll have to get it tested, and they'll have to talk to a business analyst, and there's business experts in there. There's user acceptance testing. There's a whole line of requirements that a developer needs to do. Now, sometimes a loop on that could take 3-4 months, a year to actually produce a written project. When we do a rule sprint, we're reducing that. We're writing only just enough code to make a coherent change. We're going to take that code and we're just going to run it through. And once we've written just enough to make an actual change, we're going to run that out to the real world and actually test it and try it out. And as long as it's working, we can then come back again and write a little bit more code. We check to see if the test fails, rewrite the test, and we'll just write a bit more code. And we create a washing machine effect. And those rule sprints, they could be 2 weeks, they could be 2 minutes. And so what happens if we have this continual assurance, test-driven development, which allows us to always be able to know what state we're in, always have an idea of whether what we're trying to do is achievable or not.
Yes, let's get into the tool for testing, right, Mike?
Yeah, so what we'll do here is I'll share my screen up, and then I'll take the very risky thing of doing a live presentation of software. So
You can.
I can do it. Trust me.
You can do it.
I'm a developer. So we have the rate subsidy here. Here's the rate subsidy. I've just published it out. You can see it's come in on the slide here, and we've got down the bottom the current outcome. And you see those outcome, that is matching this outcome up here. And so when we run that through, it's going to ask a question on my phone. Am I a rate player? Yes, I pay my rates. And do I live in a residential property? Yes, I do. Yes, I do. And is it my usual place of residence? Yes, it is. So we've answered 3 questions there, and now we've got enough information to get a green bar. And so what we'll do is we'll ask SmartLegal to represent that. So it's pushing out the log law, checking it. It's realized that nothing's changed in material in the law, so it's actually just going to model the whole thing through. So that's what I've just entered on my phone. This could be your phone. I could look at the immediate results of what you've got. I can see I've got a rate subsidy, and I can see that these questions have been answered. I can see I've probably got an amount in here. If I look at the answers over here, I should see my rate subsidy amount, which is going to be minus 15,000 again. But you can see there that the retirement village questions were never asked because I was eligible, because I was a rate payer. So if I pull that back, and I'll just recycle this question here. And it's not my usual place of residence. In fact, I do contribute to a retirement village, and I have a residential unit. But I don't live there because I'm a backpacking retiree. So I'll just say no to that. And you can see there that I don't actually qualify for a rate subsidy due to my backpack. And I can run this through here again. So I can look at that and say, well, what happened there? What happened to my law? I thought I was going to get a rate subsidy. I'd like to take that apart. So we'll just remodel that. And now I can see that it failed up here. So this amount never got through on the true condition over here. So I'm not eligible. I'm not eligible because I'm not a rate payer, and I'm not in a retirement village. And it's actually quite clear why not. And so looks like if I want to retire, backpacking is probably okay, but I'm not going to get any rate subsidies for me. But I think I prefer to do it that way. Okay, so looking further into it, we can sort out this calculation down here. So if I say, well, actually, I'm going to create a state where I do have dependents. I'll say, do you have any dependents? Yes, I do. I have 2 of them. My household income is, what, 40,000? 40,000. I have a base rate is entered by the computer itself. My actual rate is 2,000. So I've got a few things there that will work, and I'll just change. I won't go through the app this time. I'll change it in here. So I'll say that I am a rate payer. So I'll say yes, yes, and yes to those. And all of those answers will give me an actual calculation. So I'll be eligible, and the calculation can fire up. So what I've shown you before is a single scenario off the phone. And I'm now doing it through the workbook. And I can see all the answers coming through. So it's actually me trying it out, working in a closer place. It's like this. So I can see the wage subsidy, and I can see now I've got a rate subsidy amount of 96, and there's a 100% chance of me getting that amount. Incidentally, this table here is just a table. So of course you can insert charts and stuff and have a look at the different outputs and what you want to do with it. So it's all full of analysis that based upon whatever analysis tool you've got hanging off the back of the log law. Really, I use Excel, but there's lots of available tools for modeling this stuff. And the other thing to look at then is the weightings. So we looked at these probabilities, and you understand how the probabilities grow. What I'll do is I'll actually create a bit of a population. So I'll say, well, I actually had 5 people say that they didn't, and and 2 say that they did. And I'll put in another proportion of answers here. And there's a couple of answers I've already received. Somebody said that they didn't know. And there's a couple of unsure residents there. So that's just a scenario I'm running through the engine where I've broken down multiple cases. So instead of running through a single case at a time or looking at the 7,000 possible outcomes of this particular legal thing, I've actually weighted it just so I'm doing a scenario where so many pets said this and so many said that. And so when I look at the model coming out, you can see that the proportions have all moved around. And so now these questions have rebalanced. And you can see then that the outcomes have also moved around in proportion to the proportional changes up the stream. And you can see that the final answer is now different to what it was before. Now, from a weighting point of view, and this is particularly important when you want to model things that are more important of each other, or things that carry different levels of risk, for instance, or assurance. So obviously, I don't want to know about uncertainty here, but I'm willing to put it with a bit of uncertainty regarding residency. So if I'm going to look at that from a weighting point of view, then I should be able to weight something over here. So actually, when I get to the eligible, I want to get rid of doubt. And so when it says eligible up here, I'm just going to say, actually, I'm only interested in falses and truths. And I'll just tell it to rerun that through. And that's going to rerun the whole model through again, give me the breakdown of answers in the groups that they came into. And on the opposite side of it, it's going to give me those proportional outcomes that I can then feed into an operational system or some kind of decision support system or whatever. The questions are still coming upstream from the users, and you can see there that eligible has now lost its doubt and rate subsidy has lost its doubt. And when I look at the question over here, the answer for the rate subsidy is here. There's a 10% chance of getting it and a 90% chance of not getting it, which if I look at the model, I can see is proportional to. And so what we've done here is we've created log law, which has all the scenarios that we could want to come up with. And it's got provability at every stage that the scenario is doing what it should be doing and that the law is operating as we expect it to. And that means that we're able to trace to and from any one of these nodes. So if we decided from here we wanted to understand what fed into that, who are the precedents on that, and who are the dependents, we can actually trace up and down the flow. And some of these legal systems get very complex, 20,000 nodes or more, all showing interrelations between the law. And because we can test it to this degree, with this level of control, we have a very high level of quality going into, and value, if you like, for our testing personnel, because they're able to look for contradictions. Contradictions can't get through the logic of the tree here. If there's a contradiction, then you can't even enter the node and it will show up on the diagram. Loopholes in the law, if you run a scenario where somebody finds a way around a bit of legislation, you can actually model that scenario and work out how to correct the law to stop that loop, to plug that loophole and put an amendment into the law. Also, it allows us to simplify the law, to look at each of these elements in turn and understand how it fits in relation to the whole, and to find patterns in the law and to see whether there are ways or ways of getting a fairer outcome or a more balanced outcome through the modeling of it. So we'll look at it a bit further in the apps. So we've looked at this and we can see that there's rate subsidies and all of these different outcomes, and we can see we can reset the laws. But when we're also operating in this, we're not talking about a specific language, so we can just flick the language. So we're going to flip the script now, and we're heading off. So here I'm just practicing my Chinese now. So we'll ask, am I resident in China? Is that right, Gladys? Am I normally resident in China? And so if I answer yes to that, then looks like I'm going to have to pay some income tax. And if I say no, then, well, are you resident in the last so many days? And if I say, yeah, well, yes, I am. Looks like I'm paying income tax again, but actually, no, I'm not. And so the outcome is something that is abstracted away from human language. The computer's reliably interpreting the model that sits underneath it and putting it out. Now, this app is just an example of what we can attach to. We can attach to operational systems downstream, decision support systems downstream. We can build direct feeds into databases from these outputs. We're already in a cloud database as it matters. So we're in a serverless cloud environment that is just an Azure database. And we can fire the same code, which only doesn't care where it lives, and that can go and live inside an operational system. At the other end of the scale, we can pick up the questions, and those questions we can pull in from operational systems themselves. So we can plug in a payroll system and start attaching them to these nodes. We just need to identify where the node attaches to the payroll system and feed it the information. And the things that we haven't attached yet, well, they'll just default out and give us various outcomes until we've attached all the nodes and we end up with an operating system. The point of all of this is that at no point is there any doubt, apart from the doubt in the law. There's no doubt into the interpretation of the law. And so this gives us the laudable goal of achieving a level of isomorphism. Now, isomorphism is a term we like to use. It's a little bit like a holy grail in that it's difficult in law to think of computers being able to do what law does. So isomorphism means equals and in the same shape. So in the shape of. So if I change the shape of something, it's like the shape of law, a bit like the shape of water. The shape of law, what is that shape? It fits into whatever container you give it, really. So law will mold around the context of the scenario that you're in, and you're able to, by being certain of the mold that it's put into, say that it is equivalent, whether it's in written text or in computer code. And all we're doing here is separating out the knowable, the determined outputs from the unknowable. And we just push those unknowables out to the back end as questions. If we hook them into operational systems, even the doubt can be measured using AIs or such like. And so that leads me on to a set of applications, really, for all of this. So I've seen enough of that, and so back to my talking head. So we've had probabilities. We've got how people interact with the effects, and then we also have the results and where the results fire out to. So if we take the results and they go into an operational system, and we, as lawmakers, develop a piece of consistent code, that one piece of code we can push straight out into a client or into any consumer of the law and sign off on it. And so the people who made this law, this code is equivalent to that piece of law, and here is our proof. And you can implement this code in any language, in any computer language, in your native computer language, into your operational system. And when you do that, it means you don't have to interpret it. There's none of this, well, we thought it meant that or whatever. We've got a skeleton that we can bring in, and it's only the doubtful bits, the bits around the outside that we need to hand over to the humans for more interpretation. And then we have the scenarios. Of course, we can run through the scenarios. There's the group scenarios, and there's the individual scenarios. There's the exceptions and all of that, and the methods for putting that out. And they go out as part of the proof. And all of this is under the collection of transparency. We can see all the way through from a line of code to comment on a line of code that will lead you from the actual execution of the code. We can trace it back to the log law. Through that, we can get to the concept model, to the greater arc of all law. And that will give us enough information to know if there is any doubt or any ambiguity, that we can go directly to the paragraph, the line. I haven't shown you that on the phone app, but it actually has a web link as well. So at any point, you can click on a legal phrase and it will take you to the web definition of that to help you out if you need more information. And then we start getting into the really science fiction stuff. Because these laws are held as these little shapes, we can take one of these shapes and blend it with another shape. The blending of law is difficult to achieve unless you break them down into individual questions and then stack them. So, and when we blend into a law, really what we're saying is, from my point of view, the law that I'm interested in looking at is listed like it's the wage subsidy, but there's also a question of residency, and maybe I need to look at the definition of residency and bring that in as well. And then at the same time, I would like to look at what my retirement options. Am I fully retired? I'm not really sure, so I'll have a look at what the definition of retirement is, and I can build my own personal tree of law. A little connection of bits that we can bring together, and they all merge into one and give me a personal view of the law. And then that leads me to the tricky question of isomorphism. You know, is this isomorphic or not really? My personal belief is that it is isomorphic, and that law and code are equivalent. I've hopefully proved that here. I'd like to know any levels of objection to what I've shown, because I feel that it's self-evident that you can get to a certain level and you can have that framework to work out the deontic or the non-deterministic parts of law. So, and yet we'll never get there with the non-deterministic stuff, because ultimately we're in the world of the artificial intelligences and humans. Now, the interesting thing about artificial intelligence is that it looks at all the information and it brings out a weighted balance, and you've seen how to hook in those weighted balances. And we could take an artificial intelligence output and plug it directly into one of those weighted outcomes, and that would then, regarding on the answers that come in, the numbers would shift around and they'd all balance out in the end. The purposes of an AI in this case is not really to define the structure. Really, that's a role that a legal engineer is probably better off suited to do, and AI can certainly help in the creation of these structures and provide some support. But ultimately, we're looking for an answer to the deontic questions, those questions that appear at the beginning. So the possible answers to those a human can offer. And an expert in a domain would also offer answer to those, and AI may offer a balanced answer to those. Each of those inputs can be differently weighted so that an expert in a field could carry more weight than a layman in the field, and AI might actually be the thing that's hooked directly in for that particular question. And so you would see collection of systems, all the different parts coming together, all held together with the humans, all operating under the Better Rules framework, and all the humans working with their phones off their devices. And we all love our devices. So this is just another way of spending more time with them. So back to you, Natalia, I believe, because that's the end of what I have to say.
Thank you, Mike, Gladys, and Adrian. You've delivered such an amazing masterclass. You've taken us from the now and what you're doing end to end to the art of the possible, Mike. So really, really grateful for that. I personally look forward to building my own personal view of the law. What a fabulous format. Gladys and Mike, you work together so beautifully through this workshop. Now for Q&A, we have a few questions. So a question from Paul Handel. Adrian, you did answer this question, but Mike, you may want to add to the answer. So the question was, what programming language is used to code the rules?
Okay, so SmartLegal uses our patented transpiler to code the rules. Now, a transpiler, in computing, you have a thing called a compiler, and what that does is it takes a computer program written as text, and it goes through a number of transformations and turns it into computer code, which it then implements directly onto a chip and executes as a program, right? That's compiling a computer program. A transpiler takes a computer program and takes it apart, and then it reassembles it as a computer program in another language. And when the transpiler takes it apart, it just keeps the intent. What am I trying to do? Not how I've done it, not how it was implemented in C or Java or whatever language. It just takes away, I'm trying to add these two numbers together, I'm trying to take this average, I'm trying to group these numbers. And it puts all of that out to another computer language for it to implement. And so what we've done here is we've taken the transpiler and we're effectively applying it to log law as if that were a computer language, and then we're writing it out in any other language. And so the language that it's written in is actually written in any language and is expressed as any language when it executes, which is quite sci-fi. So ultimately it's just held as little Q&A questions in the background, and then it compiles itself into the chosen language, and it takes in reality, it takes about 2 weeks to bring in a language it's never seen before. And so when it executes, it then chooses the language it's going to fire into and operates off that. So we're natively working in a serverless Azure database, and it natively speaks Azure SQL.
Awesome. Adrian, I'm just wondering if you want to say anything else in response to the question about how do you assist users who need guidance on answering questions? Would like to elaborate.
Mike hit on that. We link out to explanatory material. So if someone hits a question that they need some help with, there's links out to explanatory material. So yeah, was that the question, Natalia?
Yep. And Gladys, I'd love you to answer a few questions too. Just a general question: could you please address, what are the mistakes that people make when taking on initiatives like this, rules as code?
Yeah. Over and over again, what we see is, I think Adrian addressed it in the beginning. It's just garbage in, and you can, put in a lot of garbage into a system, right? It's that upfront, that thinking, that interpretation, that all that work that's involved, and then with a tool like SmartLegal, and it just makes it work beautifully when you've got that thinking straight. So that's what I encourage everybody to do, to have that clarity of thinking beforehand.
Awesome. And we have a question from Mick Shea too. Please, I'll ask the panel answer this question, whoever would like to. Do you find the questions have to be focused on the right target? So do you work full-time versus do any of your employees work full-time? So you have to decide at the beginning who will be answering the questions, right? Who'd like to tackle that question?
That's absolutely correct. But law is always personal, and law is always about personal obligations. There is no law of computers because you can't put a computer in jail and it doesn't think. So I mean, there's never been a case of Adrian versus a computer, or anything like that. So there is always, necessarily so, because it's regulating human activity, necessarily a human dimension to law, and we can always find that within the law itself. So I mean, there's always an obligation, and it's always on a person. So yes, you have to do that as part of your analytics. Gladys has already shown us. You'll go through and you'll isolate who has the obligation towards who, and what, and from that you're guided by your analytics as to how you frame the question. So yes, there is an art to that. That's part of what a legal engineer does, is to replicate the personalities within the law in code. Yeah.
Wonderful. And this is a very much related question. Transparency. Adrian, could you talk a little bit more about how the SmartLegal platform promotes transparency in relation to lawmaking?
Sure. Well, I mean, I think we've demonstrated tonight that you can, and this is what Mike said as well, you can go from the far end of computer code back to the source in written law, and you can see a one-to-one correspondence right across that whole spectrum, and that's why we're so interested in really push the idea of concept diagrams and decision trees as intermediate aids to transparency. Once you can see from the written word through the concepts through to the log law, you've got and that is transparent. That's English. A little bit of effort, and you can intellectually see the one-to-one correspondence up to log law. Now, once you get to log law, as Mike said, we've got the transpiler. You hit that button. There's patents. There's a whole lot of logic. There's all the heavy scientific lifting, and out the other end comes the code. So you've got log law, and you've got the code that comes out the other end. If they correspond, which we can prove, that's provable, and you can go from the log law back to the original source in a transparent way, then you have your end-to-end transparent decision-making process where you're not leaving it to a computer. That's the bane of this area, is like, it's a black box. We don't want black box algorithms. That's what I was stressing at the beginning. We have an end-to-end process where we create the algorithms in a transparent way through Gladys's processes. Those algorithms are transparent, and then, yes, they are executable, and that's what we want. But we need that algorithmic transparency built up all the way through the process. Otherwise, to be honest, it's just another hand it to the computer experts and take what you get. It's not rules as code. That's just the status quo. So I mean, transparency is everything, and our platform is designed around it.
And I want to add to that traceability is so important. I go to so many organizations and people just say, Gladys, just tell me what my rules is because I've lost track of it. And my system's taken me hostage. I don't know how we give rating to our products anymore. Can you tell me? Because it's gotten lost. And, and their agreements don't agree with what they've implemented in their systems. So this whole traceability that, and it's just in terms of efficiency, in terms of customer service, in terms of, citizen-centric or customer-centric, it's key.
Yeah, and ultimately trust in the system, right? And that's so important for rule of law. Audience, please post your questions in the Q&A. But before further questions pop up, I have a couple of questions. So what is required for broader adoption? In fact, how to accelerate rules as code globally? I'll open this to all the presenters.
Well, I would say tool is, because I've been in this for a long time, 25 years, right? So I think the tools like that makes it happen is important. I think that's gonna make it, and just like, this is history of technology, right? When we have databases, before the oracles jump in, it's just starting out, but the tools will make it possible. And the other I wanted to say is a different way of thinking. What people don't realize is working with rules, it's different way of thinking. And a lot of people who work with systems and all that just don't have this declarative way of thinking about rules. And people are used to working in a procedural way. And so that needs training, education, and needs time. And I think that's what, we've seen it happen. It's happening in the space, and so Adrian, if you have any magic, and Adrian and Mike, if you have any magic wand that can make it happen faster.
Well, use our tool would be a good start. It's a package, right? You have to have exactly what Gladys said, and the tools are important. A lot of people say, "Oh, we need a methodology," but in the end, you need production-ready code. And you need to work in a fashion that will create that integrity in the code base. And I think what will actually accelerate it is when people realise that it's been done. that it is transparent, you can see it from end to end, and you can do it at home, right? And then people will go, okay, so I can see my code base from end to end. I can have this assurance. I can work with this. These tools are not too hard. And then lo and behold, I mean, you know, everyone learns how to work the VHS machine. I mean, so a lot of it's to do with accuracy and integrity and transparency. And I think once people start looking into these things, they see that those things exist and they get confidence, and then the way people work starts to change. Yeah.
Mm-hmm. So RSC projects. Oh, sorry, Mike.
I had something to say. Yeah, I did. Yeah.
Love to hear your input. Thank you.
There is the interesting thing about the whole movement is that it's been gaining traction. It's been a few years now, and it's been gaining a lot of interest internationally. And I talked to one of our friends in Parliament, and he was basically saying people are set in their ways. They don't want change. They are happy with what they do. They've trained to work with paper. Computers aren't law. That's the statement, right? And the only way to actually make a change and to accelerate a change in this area is for a global world event to occur to change the way that people work. The reason for this is the COVID subsidy. We looked at that as an example, COVID-19 wage subsidy. The law had to go out there. People had to be helped. It couldn't wait in Parliament with people writing these things down and arguing and debating them. It had to go out. And so we can model it to a high degree of accuracy and push laws out earlier with a higher quality in them that are more rigorously tested before the law itself has run out. Because by the time the COVID law, wage subsidy law is out, it's already gone. So we need now, in this world that we're in, rapidity, an ability to control what we're seeing. We need to be able to factor it up. The slow, ponderous methods that we do that just work, and there's no denying that they work, they don't work in this world. Mistakes get made.
So what would your recommendation be to those of us that really like to see rules as code succeed? What can they do in terms of lobbying regulators and so forth? What can the everyday person do to assist with the rules as code movement?
That's an interesting question. I mean, it's really up to policymakers in the end to take on board the advantages. I mean, Mike's talking about speed to market, if you like. I mean, there's a myriad of other advantages as well, and one of them is actually like that personal relationship with the law that we talked about earlier. I mean, what happens is the demand happens, right? I mean, people have very powerful computers in their hands, and everything becomes an app, and people want to know the answer. They type it into Google, and they want to know, am I liable, for whatever, or am I not liable for whatever? And that demand builds, and I think policymakers, they start seeing the advantages in participating in people's digital ecosystems, and I guess it's a supply and demand thing. I mean, who leads the evolution or the revolution? I'm not sure what an individual can do, but I certainly hope that as we go on, we're doing lots of proof of concepts at the parliamentary level at the moment with our platform. Around the world, we've got UK, we're trying to get into Australia, Natalia, trying to get there, New Zealand, Greece, Italy. So these proof of concepts are happening now, and the policymakers are getting to see it and get a feel for it. And I feel that the demand is there. I mean, from the personal point of view, and we talk to businesses as well. Businesses want to comply with their obligations, and they want to do it in a digital environment, and they want it clean and easy. Banks are a great example, very highly digital, lots of big management information systems. They want to comply with the rules, right? And so we say to the regulators, you've got to provide this this service to your customers, who are the regulated entities. I mean, these are all digital people that you're trying to regulate, and you're handing them a piece of paper. It's almost ridiculous, as Mike was saying. I mean, here's a piece of paper, and you're giving it to some very digitally savvy people, and that's happening more and more. at a personal level, I mean, an iPhone is as powerful as any computer in the last 10 years, for goodness sake. So there's a demand there. And I think policy people, as it gets proved out through the proof of concepts that we're doing and other people are doing, we will see it happen. I think it's what's happening. Anyway, yes, sorry to ramble.
I think what Mike painted the picture of this personal law, I mean, I think that's so interesting, right? Because, I like a playbook. For me, I'm not a student. I don't need to look at the section about students. I don't need, I'm not a certain type of, earning income. So I can get at the law just applied to me. So, an everyday person, if, there's requests, if they can make it known that these are really helpful things that if the government can provide, then that will help, because, Ruler's Code falls right into all of that. So that's,
We're doing entitlement work, and I think that's really important. People want to know their entitlements to social welfare benefits. So, I mean, banks want to be, to know that they've got their regulatory regimes correct. But the everyday person wants to know, well, do I get a universal credit or not? And you've got your own personal data cloud. We're all digital people now. We all have a digital persona now, and we need to leverage computing, not just as a publishing medium, but as a computable medium to take advantage of that and give better service to people. Absolutely.
For the students on the call, both technology, computer science students, as well as our lawyer friends, our law students, what recommendations would you give to get into this space? What training do they need? Can they talk to you about projects?
You can, from my space, you can certainly get training or go on our website. There's a lot of free paper to download on this space. We talk about, rule speak, how to write that, and so forth. So if you get on our website, we also public newsletter, brcommunity.com, and there's a lot of case study, people, what they've done with rules in all walks. So if you're interested, you can go research on that. Our website, brcommunity.com. brsolutions.com is our company website. brcommunity.com is the journal.
So from our perspective, log law is an open standard, and it has to be, because we want it to be transparently used for rules. And we have a manual coming out, and we're doing training through Gladys's company as well on log law. So if people want to start putting rules together through log law, the transpiler is proprietary, and you need a license for that. But you can certainly get the non-computer part, if you like, of the process done up to writing your own log law, and that's freely available. There's no license fee for that. So yeah, I recommend people going as far as they can without buying a license. You're welcome to buy a license, but I mean, if you go through the intellectual process, go through Gladys's company, get some training, we can go right up to log law. Log law is freely available, and you can write that. And yeah, that's a good way to get into it. And I think that you do need legal training or a policy analytical mind, but you don't need computer training. That's kind of what the point is we're trying to make here, is that we have traceability for normal people. The computer takes care of a lot of all of the heavy lifting into code, but you need to have the intellectual ability to go through the process up to and to write the log law. So I mean, it's not for everybody, and I think that's, yeah. And there are a number of projects available at the moment. The Greek project, I think, has an academic angle to it. There's other projects out there. Most of them are commercial at the moment, but I mean, yeah. So I mean, we'll just leave that for now. But yeah, there's certainly projects emerging. Yes.
Fabulous. Look, we have some excellent comments by experts in the field, including Guido. There's in the interest of time, I'll just pick one other question to ask. I think this, Adrian, is a question for you. I love this question. So the question is from William. How does it deal with interpretations? So how does your platform deal with interpretations? How can you ask if something is beautiful in law, and yet lawyers could sit down and answer that without knowing the exact rules they consider? Your comment, please.
That's a great question. I mean, it goes to the heart of everything, really.
Yeah.
The question that people ask, well, what's fair, right? Now, I mean, the point is that within an algorithm, you have a process and you need data for it. The process, what we do is we create a framework. This is what Mike was talking about with Diontic versus non-Diontic and deterministic versus non-deterministic. I mean, what's beautiful and what's not beautiful is non-deterministic in that sense, and the computer can't compute that. But you can leave a space there for it to be computed as part of the algorithm by the right person. You will need to go and talk to that room of lawyers to find out what they think is beautiful. So we don't solve every interpretation problem. We can't. Computers can't do that, but you can actually build out. This is something that I found very interesting, and we get into existential philosophy at this stage, but there is absolutely an ability to say what is beautiful. People can agree what beautiful is. So it is algorithmizable, and you can put that algorithm into a computer. The algorithm might be ask 10 people and take the average answer. Okay, and that in itself is an algorithm, right? Now, it's not the computer interpreting it. What it is creating is using the computer to run the process, create the framework, and to make it reproducible and available to everybody. So that's what computers are doing, right? They provide the framework, the algorithm, and you have to fill that data in. And yes, some data points seem insoluble from a computer point of view. Absolutely, you know. But they are still points in an algorithm that you can go out and ask. And so what is fair? Well, the answer is go and ask Mike. And so that's what the computer does. The computer goes, okay, I can't answer that. Let's go and ask Mike. You have to write that in. You have to tell the computer to go away and do something else. You can't just ask it to work out what is fair by itself. That just doesn't work. In actual fact, the question had the answer in it. The answer is the computer goes and asks the room full of lawyers, and that is the right answer, because I mean, unless you can write an algorithm, and you can write an algorithm, you could say it's you could use a random number generator, you could use whatever it is, you could just go and ask Mike. Whatever it is, it doesn't take away from the fact that it's still an algorithm and a computer can run it. It's just that it's a different way of thinking about rules and an algorithm. Because people want the computer to answer everything. I don't want to find out what fair is. I just want you to tell me what fair is, Mr. Computer. And that's not how life works. I mean, we aren't actually advancing or going backwards in any way, shape, or form. It's still an issue for a judge, what is fair and what isn't fair, right? And the computer can only ever aid that, or at least point out where the judge needs to fit into the algorithm. So yeah.
Fabulous. And Nick, I think we'd agree with you absolutely that all regulators need to be thinking about rules as code, and as quickly as possible. The benefits are far-ranging and very important for the digital world that we live in. So just to conclude, on behalf of the Australian Society for Computers and Law, thank you, Adrian, Gladys and Mike, for sharing your deep expertise in this area and being so generous with your time. Truly inspirational. Law, computer science, public policy, all blended together beautifully. So thank you also to our friends at the UK Society for Computers and the Law for hosting this event on your platform. Great job, Simon, there in the background. By way of concluding words, the RAC movement is moving quickly. RAC projects emerging around the world, and New Zealand, Australia, Canada, our presenters today are working very hard in this area. And these are truly transformational projects. The New South Wales Department of Customer Service delivered its first regulation natively codified, being the Community Gaming Regulation of 2020. Great job, team. As I mentioned, this is the second of our masterclasses. Do join further masterclasses. If you'd like to learn more about Rules as Code, do download the OECD RAC Innovation Primer. It is a fabulous work, an excellent paper by Alex Roberts and James Mohan. Also the New South Wales Treasury paper on regulating for New South Wales' future, which was published in July last year. So we had over 300 people register for today's event. So thank you once again, and we'll be sharing the recording of this event with a broader community. Just a reminder also to join the ANZ RAC Community of Practice founded by the Society together with Code for Australia and La Trobe University. Links will be sent to all that registered for this masterclass. And that is me for now. Thank you, and bye for now.
Thank you. Bye-bye.
Thank you.
Bye.